Alright, welcome to episode 55, Deriving a Functor Instance, and we're going to do this for our WebPart type we've been working with from the web server series that we've been working on. And we're going to do that because, for one, the way that we were writing that web server is going to run into some problems when we try to chain together multiple web parts. And of course, by chain I mean monad. In this case, we're going to start with Functor because it's quite a bit simpler. So we're going to start with Functor, and we're going to look into how we would do that. There's going to be a lot of JavaScript specific stuff in here, which is not necessarily important that you understand, but we do have to go through that to be able to do all of this good stuff. So we've got our web part, and we're saying that our web part is a function from some A to an either of a future of an A. And technically, yeah, we're saying that that's a 404, this is a 500, but this is what our type is. Our type is this function signature, and that's what we want to encode into the language, and we want to be able to think about it as though it is this whole thing rather than it being all of these separate things of that it's an either and then a future nested. So we want to be able to deal with it as one thing rather than as a combination of things. So we're going to import some fun stuff here, and then what we're going to do is we're going to create a WebPart function. And basically, what this is it's a function that if you give it one of these things, we're going to say it returns a WebPart of A. So if you give it this function here that we've been saying that it will return you a legit WebPart of A, which is nice because now we can start extending the prototype of this WebPart. And we can do things, and we can make it a functor. So we can map over whatever this thing is, which is what we're going to show today. So just a quick review. A map is something that functors can do. And in fact, to be a functor, you have to provide an implementation for map. And so basically it says that if you have a functor of A, and then you pass it a function from A to B, then you can return a functor of B. And so if we were to take the functor F out of this and we were to insert our web part instead, then we would get our specific implementation would be given a web part of A. If we have a web part of A, we have a function from A to a B, then we can return a web part of B. And so here's a very, very verbose way to implement that. We're setting WP equal to this so that our this is bound correctly. We don't run into any issues there. WP just for web part. And then what we want to do from this, because we know that the result of this has to be a web part, but of B this time, what we can do is now within our map we can say we're going to return a new web part, which makes sense because that's what ultimately we're returning. This web part A here is technically this WP.fn. So we're going to return a new web part, and it'll receive some value because it's a web part. So a web part we know takes an A, and finally has an A within its future. But that's 2 levels deep of functors because either and future are both functors. So what we can do is we can pass this value here into our function that we had that was stored within this web part. And then we can map over that to get to the either. If we map over that, then what we're going to get into is whether it's a 404 or a future of something. And then we can map into that. Actually, this should be a future. And then we can map into the future. And then we can finally take the value out of that future and apply it to this F. Now, so this is very, very verbose, and as it turns out, this is much simpler to write in a more point-free manner. And I've actually written that as well here because I think this is actually a lot cleaner. Basically, to map is basically saying we still have to do our fun WP equals this kind of thing, but then we can just return a new web part because we know we have to return a new web part. And that, what we want to, the function that we pass to that web part is just the composition of the function that we already have and mapping in and then applying that to the map of whatever this f is. It's absolutely equivalent to this as far as the end result, but I think this is a lot cleaner, and you don't have to try to come up with all these different variable names and everything. So this does the exact same thing as this. If that doesn't make sense to you, play around with it a little bit, but basically this first map here does the same thing that this map does. This map does the same thing that this map does, and then this f is right here, and because of currying, that means that this will take whatever the result of this function was. And because WebPart technically has a value, some sort of an a here, and then we could do the composition, and we could then apply the a out here. But you can reduce the terms on either side, and we can remove those a's. And so that's how you end up getting all the way down to this. So then to do all of this, we're going to have one other thing, because the way we've got all of this nested within JavaScript, we're going to provide a run function. Basically what that's going to do is on the prototype, it'll just get the function that's inside of this web part, and then we can supply whatever the initial value is. So this is the concept of kind of a purely functional kind of thing where nothing actually happens until we run it. And so that'll actually kick everything off. So here's what this would look like. So we could create a new web part, and we're going to take some sort of an x, and we're going to pass a function to this web part that's an x to an either of a future of whatever that x. So this is kind of like our identity for web part. And then what we want to do is we want to be able to map over that. We're going to call our map function. We're going to say x goes to x plus 1. And that is our web part. So this returns a web part. And then what we want to do is we want to call run on it. And now we can pattern match in and see what all we're going to get. So now we can say run this web part with the value 1. In this case, we're just using numbers because it's simpler to think about. But ultimately, this, from the web server standpoint, we'll start getting our entire HTTP context flowing through it. So then we can use some of the fun helper stuff with from Ramda, actually. But to get the either, and then we can map whether that's we can get the either, so that'll take either the left or what ends up being a future. We can fork that future to get either the error of the future, or then finally the OK. In this case, this is what we really expect to log, is whatever the OK value is here is going to equal 2. This is kind of like a little unit test if you want to. And so if we were to actually run this, this should all work. And you see we get 2 equals 2. So there you have it. The cool thing, what we end up getting to here, the big benefit is that now we can think about a web part as a thing. We can map over it. We're not thinking of the web part necessarily as being the combination of a bunch of different things. So if you have something else that you're dealing with where the type you end up with is an either of an IO of a blah 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 whatever else, you could create your own type that combines all of those things, and that's exactly what we've done with WebPart. Hope you enjoyed it. A little bit longer episode today to make up for the short one yesterday, and let me know what you think. Thanks.